All right, so today what I wanted to do is go through a few more of these um, uh, polyatomic ions. So let's take a look at that. And I'm going to come over here and I'm going to pick polyatomic ions. I'm going to add a response to mine and then go on in. Um, so in these, what you are looking for is these last three letters, okay, ATE, ATE. And that is different than what we used to work with. We have worked with things like the element, which is chlorine, and we have worked with the ion, okay, during bonding. We worked with the ion of chlorine, which we knew, you knew, was IDE, chloride, okay? Chloride is all by itself just the Cl. When we see the ATE ending, we know that the symbol is Cl, still chlorine, but the ATE means we put some oxygen on it. So sulfate means we have sulfur, but we put some oxygen with it. Nitrate is nitrogen, and we put some oxygen with it. Now the question is what number comes after here? And so what we're going to do, I'm going to take a quick journey here and add in a periodic table right there so that I can see this. Okay, so what we're going to do is look actually for those particular elements, and I am going to be using this T43, T43, where the T stands for 3, the 4 for 4, and the 3 for 3. So chlorate was my first one. It's right here. It's in the 3 part. And so therefore I know it has, well, not like that. It has 3 oxygens, okay, like that. SO, sulfur. Well, I got to come over here and find sulfur for sulfate. It's in the 4 part, okay? And so I know that it is sulfate, okay, like that. Nitrogen, all right, nitrogen over here is in the T part. So the T stands for 3, so I know that there are 3. Now, as we look over at this other side and we say, okay, I got the 8s, but now it's 8. And so we're going to do one thing that's a little bit different. So we have, I'm going to add it up here, chlorate. Okay, so the chlorates have oxygen that follow T43. And then we also have something, chlorite. And chlorites, or anything with that ITE ending on it, is going to be one less oxygen. So instead of NO3, come over here, and I'm going to do green again. It's going to be NO, not 3, one less, so NO2. Sulfate, ATE, we looked at the periodic table and there was a 4 of the T43. So this one, S, still has an oxygen. How many, what's the number? Well, it was a 4, but since it's ITE, it's 1 less. So sulfite. All right, fluorate, okay, it's on the right side of the table where the 3 is, but fluorite is going to be 1 less than 3, or 2. All right. The charges. All right. When we go into the periodic table, we know that this is -1 and everything in that column is -1. Over here, we have to start over. So this is going to be -1, -2, and -3. So that first row goes -1, -1, -2, -3. The rest of the rows go -1, -2, -3, and then they go back down, -2, okay? That's for those 2 rows. So we can come back here and look those up, -1, -2. Nitrate, remember, that's where it starts over, -1. Now in the ITEs, This is easy because the charges don't change. It's still -1. It's still -2. It's still -1. No change. All right. Hydroxide, it is OH. That's what it is. And it has a charge of -1. The symbols must be in that order, O and H. Ammonium. This is the only one I'm going to give you where it is polyatomic and it's a positive polyatomic. It's a +1. All right. So I have put a copy of that in my portfolio where you are welcome to look at it. And let's talk about the next activity. So when we do chemical reactions, all right, we're looking for patterns of the way that elements and things join together or are taken apart. So I have 5 different pattern boxes, and all I want you to do is move these and look for the similarities and differences among these 14 boxes, uh, and figure out that, okay, well, let's see, I have 2 things on the left side and 1 thing on the right side, okay? So let's see, oh, all right, I have 2 things on the left side and 1 thing on the right side. Yeah, so those have a similar pattern. So that's what I want you to do. Find the 5 similar patterns. And then there's another one of these, but instead of using little pictures and symbols and numbers and words, I'm actually using some chemical symbols, all right? So that is your work for the next day. All right, so enjoy.